So today we'll talk about complex numbers. So during the years of math, you learned whole numbers, integers, rational numbers, irrational numbers, and real numbers. And we also discussed right up to this lesson that if you have square root of -4, you say it has no solution, or I cannot find, is not a real number, right? That's what we were saying up to now. And it's true, it's still not a real number. But here is the time where complex numbers come in place. So basically, let's write a definition. The imaginary unit I, right, just the letter I, is defined as I equals square root of -1, where I squared equals -1. So basically, by introducing this imaginary unit I, we are actually going to be able to calculate square root of negative numbers. They are still, the answer is still not a real number, it's a complex number. So basically now, square root of -4, we can actually write -4 as 4 times -1. So we can write it square root of 4 times I squared, which is going to give us 2i. So square root of -4, now it's 2i. It has a value, but it's a complex number. Square root of -9, for example. Again, you can use the same method that I did above, or we can do square root of -1 times 9, which I can write square root -1 times square root of 9. Square root of -1, I just define it here as being I, so it's 3i. So again, another one. Well, what if you have square root of -3? Well, this is not a perfect square, but this negative can come outside as I, and then we just keep square root of 3, right? So all it happened was square root of negative transformed into I. Or, for example, square root of -80, we can write it I square root of 80, and you can simplify 80 as 2 times 40, 2 times 20, 2 times 10, 2 times 5. So basically it's 2 to the 4th, which means 16 times 5. So it's I times 4 times square root of 5, and I just want to make it a little bit nicer, 4i square root of 5. So that would be square root of 80. So in general, a complex number in general has this formula, or this form, z equals a plus bi, where a, it's the real part, and b, it's called the imaginary part. So, for example, we can have z sub 1 equals 3 plus 2i. So here it is an example of a complex number where 3 is a real part and 2 is an imaginary part. z2 equals -i. Well, the real part, where is the real part? Well, I can write it like this. So the real part is 0 and the imaginary part is -1. Another one, z3 equals 5. Well, look here, I don't put any I. Is this a complex number? Yes, it is, because I can write 5 plus I times 0, right? So real part, imaginary part. Okay, now what did you do with, what kind of operations you did with numbers before? Well, the same are going to do today, addition. So if, for example, you have, let's say z1 equals 3 plus 2i, and z2 equals -4 minus I, and we want to add them. So if I want to add z1 plus z2, well, I'm just gonna add like terms. I'm gonna add the real parts together, and I'm gonna add the imaginary parts together. So we get 3 plus -4 plus 2 minus, what is in front of this I? 1i. So basically we get -1 plus I. That's the sum. Let's say we want to subtract them. So I want to do the same with the same number z1 minus z2. So it's going to be 3 plus 2i minus -4 minus 1i. Well, the first parenthesis, I'm just going to keep it the way it is. And I don't even need the parentheses signs anymore. And the second one, we know that the negative changes all the signs. Plus 4 plus I. So now 3 plus 4 is 7. 2i plus I is 3i. So there you go. We subtracted them and we got another complex number. Let's say we want to multiply z1 times z2. So I'm going to write 3 plus 2i times -4 minus I. So how are we going to multiply? Well, we're going to FOIL. 3 times -4, -12. 3 times -I, -3i. 2i times -4, -8i. And 2i times -I, -2. What is I times I? It's I squared. So -2i squared. Keep in mind, by definition, I squared is -1. So this piece here, I'm going to replace it with -1. So it's going to be -12. These two are alike, minus 11i. And then -2 times -1 times this one. So it's plus 2. So we get -10 minus 11i. And we solved it. So every time you see I squared, replace it with -1. And now let's discuss the division. So let's say you had 3 plus, let's write z sub 1 over z sub 2. That's just a notation. 3 plus 2i over -4 minus I. Okay, well, before I do this division, let's calculate this. 1 plus I times 1 minus I. Do you notice what I did? I just have the a plus b times a minus b. Well, a plus b times a minus b, it's a squared minus b squared. So in our case, it's 1 squared minus I squared. 1 squared, it's 1. I squared is -1 with the negative in front plus 1. So it's 2. Let's try another one. Let's try 3 plus 2i times 3 minus 2i. Well, it's 3 squared minus 2i, everything squared. So it's 9 minus 2 squared, it's 4, and I squared is -1. So it's 9 plus 4, which is 13. So what do you notice? When we are multiplying two numbers that have this form, a plus bi times a minus bi, we get a squared plus b squared. So basically, we don't get any i's in it, right? So this type of numbers of this form are called complex conjugates. And they are helping us divide complex numbers. So here we are going to multiply by the complex conjugate of the denominator. So it's -4 plus I. So you see, I didn't change the sign of the 4. I changed just the sign in front of the I. So now, and -4, oh, let's put the red. -4 plus I, so top, bottom. So now I put parentheses around all of them. And the numerator is 3 times -4, -12 plus 3i minus 8i plus 2i squared. And the denominator is 16 minus 4i plus 4i minus I squared. Again, every time you see I squared, you put -1. So we get -12, these two are alike, minus 5i minus 2, right? 2 times -1. The bottom, 16, these two cancel, plus 1. Well, why did I put plus 1? The negative is from the formula, and then this negative 1 from the fact that we have I squared. So we get negative 14, these two are alike, minus 5I over 17. So now you can see how I can write it as negative 14 over 17 minus 5 over 17I. So the whole reason with multiplying by conjugate is just the answer has to be written as a complex number. So do I have as a complex number? Do I have the real part here? And then I have the imaginary part here. So yes, we wrote the answer in complex form.